Hi everybody, welcome to my channel CADiologist. In today's exercise, we will draw aluminum profiles that are used usually in many applications, such as the framing system of an exterior facade cladding, windows frames, solar panel frames, and many more. As I told you guys before, I will be a little bit less explanatory in the exercises and drawing faster than before, since I have already spoke about each tool and command I have been using so far in detail through the tutorials 1 to 6 of this course. As they say, time is money. That's why I left you guys timestamps in the video timeline, so you can skip to the most relevant part for you, although I would really appreciate it if you watch the whole way through. Before you continue with this exercise, I hope you consider smashing that subscription button and ring the notification bell to receive my latest. In this video, we will draw and dimension together these aluminum profiles. When you open AutoCAD, click on Start Drawing from the interface. If the grid is activated, turn it off from the status bar or use F7 key to turn it off and on. Type units in the command line and make sure drawing units type is decimal, precision is 0.00, dry units is millimeter. Type LA to open Layer Properties Manager and create a layer named Aluminum Profile, ALU.profile. Create another layer for dimensioning and one more layer for text. Change the color of text and dimension layers to gray number 8. Change the line weight of dimension layer to 0.00. Double-click the aluminum profile layer to set it as the current layer, then close Layer Properties Manager. Make sure Ortho Mode is activated. Click on this little arrow of OSNAP and check Endpoint, Midpoint, Center, and Perpendicular modes. Before you start drawing, be sure to save the file and keep doing that from time to time to avoid losing your drawing and effort by mistake. If you are saving for the first time, click on Save from the Quick Access toolbar, choose the file location, and type the name. Then click on Save. Click on the Application button, click on Options, go to Open and Save tab. In the File Safety Precautions, make sure Automatic Save is checked and at every 10 minutes. Moreover, you can click on Ctrl+S to save your progress anytime you want. Draw a 20 by 9 mm rectangle. Activate Chamfer tool from Modify panel. Type D for distance. Specify 1 mm as the first chamfer distance and the same for the second chamfer distance. Type M for multiple and chamfer all sides. Copy the rectangle 22 mm upward. Select them both and copy left 33 mm. Copy one of the rectangles to anywhere. Select it and activate Align tool from Modify panel. Specify this point as the first source point and this point as the first destination point. Repeat the same for the second point, then click on Space. The command line is asking you whether you want to scale the object or not. Just click on Space again for No. As you can see now, this rectangle length is aligned with this rectangle width. Move it 2 mm downward and copy it 22 mm left. Activate Rectangle command through the shortcut REC. Make sure Object Snap Tracking is on using F11 key in order to track the cursor along vertical and horizontal alignment paths and snap their intersection point. to specify the first corner of the rectangle. Specify the other corner in the same manner here. Make an offset for this rectangle 2 mm outward, and then delete it. Draw an X line at this midpoint mark and this midpoint mark. Repeat the same for here and here. Move these X lines 4.5 mm downward and these X lines 4.5 mm left. Do 9 mm offset for all X lines in the same direction. Activate Trim tool and click Space, so AutoCAD can assume that all objects in the drawing area are selected. Now just follow me trimming the parts we don't want anymore. Click Space to end the command. Select all objects and type J for Join. Then window select these parts and delete them. Draw a rectangle from this corner to this corner. Select it and stretch it from both sides 2 mm. Type CHA to activate chamfer command. Specify 1 mm for the first and second chamfer distance. Type M for multiple, then chamfer this inner rectangle corners. Repeat the chamfer command, but change the distance to 2 mm and chamfer these corners. Now go to Utilities panel in the Home tab. Click on Measure and select Distance. Specify the first point at this midpoint mark and the second point at this perpendicular mark to measure the distance between them. Close to the command line, you can see that the distance is 57 mm. I want to increase it to 60 mm using the Stretch tool from Modify panel. I want you guys to know that if an object is partially enclosed by cross window selection, it will be stretched. If the object is completely enclosed within the cross window selection, it will be moved. Click on Stretch, cross-select this part, and click on Space. Move the cursor upward and pay attention to how the stretch will occur. Type 1.5 mm for the stretch value. Cross-select this part and type STR, the stretch command shortcut. Move the cursor upward and type 1.5 mm for the stretch value. Let's repeat the same steps for the profile width. Type DI and click Space for the distance command. And measure the width. The distance is 46 mm. I want to increase it to 50 mm using the Stretch tool again and in the same manner I did before. Now we are done drawing the first profile. Select it and type J again for Join. Then make a copy for it 150 mm right. Delete the inner rectangle. Draw an X line at this midpoint mark. Move it 40 mm upward. Then make an offset for it 40 mm 3 times in this direction. Cross-select exactly this portion of the object. Click and hold the Shift key along with the mouse left button to deselect the X line. Then activate the Stretch command through the shortcut STR. Specify the base point at this midpoint mark and the second point at the X line. Again, cross-select exactly this part of the profile, deselect the X-line, and stretch from this midpoint mark to the X-line. Select the object and click on Explode tool from the Modify panel. Select these lines and delete them. Window select this part. Zoom in a little to deselect this portion, then activate Copy command. Specify the copy base point at this endpoint mark. Click on this endpoint mark for the second point, then end the command. Draw a line that connects this part of the profile to the X line, and another one here. Select the lines to trim this part and this part. Select the drawing again and type J to join all segments into one. Make a 2 mm offset inward. Move the X lines 1 mm upward, then make a 2 mm offset for each one downward. Click on this arrow of hatch tool and select boundary. Click on Pick Points and pick one internal point here, another one here, here, and here. Delete the X lines along with this object. Follow me doing a 2 mm chamfer for some corners. And 1 mm chamfer for the other corners. The last thing remaining here is to remove these vertex points. Now I will draw the third aluminium profile. Draw a 20 by 9 mm rectangle. Chamfer this corner 2.5 mm and this corner too. Chamfer this corner 1.25 mm and the same for this corner. Offset the rectangle 2 mm and draw an X line at this midpoint mark. Then move it upward 4.5 mm and make a copy for it 9 mm downward. Trim these parts and delete these. Window select the drawing and copy it upward 35 mm and 70 mm. Activate Polyline command and draw 15.5 mm line here and there. Connect these parts together. Then select them and type J for join. Make sure Object Snap Tracking is on and draw a 25 mm radius circle with the center point 44 mm away from this midpoint mark. Select this object and activate Polar Array from Modify panel. Specify the center point of Polar Array here and change the item's number to 4. Explode the array and window select the whole object, then type J for join. Offset this object 2 mm inward and offset the circle 3 mm outward. Draw a vertical X line at the center point mark and move it left 1.5 mm. Draw a horizontal X line at the same point and move it upward 1.5 mm. Type BO for boundary creation and pick an internal point somewhere here. Then delete the X lines, this circle, the inner profile, and these rectangles. Do a 1.25 mm chamfer for all corners of the rectangle. Copy the rectangle from the intersection point of these two paths to this endpoint mark. Then do an offset of 2 mm outward. Type BO for boundary creation and pick an internal point somewhere here. Then delete these parts. I will do 1.25 mm chamfer for some corners of this object. .5 mm chamfer for this corner and 3.5 mm chamfer for the others. Activate fillet command and do 5 mm radius fillet for this corner and this corner. Now select these objects and do polar array at this center point mark. Change the item's number to 4 and close the array. Finally, I will do chamfer of 2.5 mm distance to the 4 edges of the profile. Move this profile to place it along the other two profiles and 150 mm away. Last but not least, hatch the 3 aluminum profiles separately. Dimensioning. Click on Ctrl+1 to open Properties palette. Change the layer to Dim for dimensioning. Type D and hit space to open Dimension Style Manager. Click on New and type Dim 01. Then continue. In the Lines tab, make sure baseline spacing is 3.75, extend beyond dimension lines 1.25, offset from original 1. In the Symbols and Arrows tab, change the arrowhead to dot small. Keep arrow size 2.5. Make sure dimension break size is 3.75. And go to Text tab. Change text height to 1.8. In the text placement field, make sure vertical is set to above and horizontal is set to centered. Change offset from dimension line to 1. In the text alignment field, check aligned with dimension line. In the Fit tab, make sure overall scale is selected and the value is 1. In the primary units, set the precision of linear dimensions to 0.00 and the same for angular dimensions. Click OK, close. Go to Annotate tab and click on Linear. Measure the distance from here to here. Place the cursor over this endpoint mark and move it slowly left. You should see a horizontal path if Object Snap Tracking is on. Type 10 to place the first dimension 10 mm from the endpoint mark. Of course, you could place the dimension anywhere you want. Click space to repeat the command and dimension this part. Type DIMC for dimension continue and measure this side of the profile. I will use the linear and continue dimension commands to measure all sides of the 3 profiles, and you guys could follow me doing the same. Select radius from the dimension list. Measure this arc and this arc. Select diameter from the list and measure this circle. Go to Properties palette, change the layer to Text. Click on this little arrow of the text panel. Create a new text style and name it Tempus Sans ITC. Change the font name to Tempus Sans ITC. Click on Set Current. Yes, and close. Click on Multi-Line Text tool, specify the first corner here and the opposite corner 20 mm from this endpoint mark. Click on Justification and choose Middle Center. Type Aluminium Profile E. Copy the text from this midpoint mark to this midpoint mark and this midpoint mark. Double-click the text to change its name to Aluminium Profile X and this one to Aluminium Profile Z. Now we need to prepare the sheet to print the drawing. Go to Layout Sheet, select the existing viewport and delete it. Right-click Layout 1 and rename it to Exercise 08. Right-click Exercise 08 and go to Page Setup Manager, where we can set the sheet size, orientation, quality, and many other things. Click on Modify. Change the printer name to DWG to PDF. Make sure the paper size ISO full plate A3 is selected. Check scale line weights and plot transparency. Make sure landscape orientation is selected, then click on OK and close. Type V-port and hit space. Choose 3 right and click OK. The command line is asking to specify the first corner or just click on space for fit. If you go to Layer Properties Manager, you can see a layer created automatically and named Div Points. It was generated when the first dimension was created in the drawing. This layer is unprintable and stores information about definition points of dimensions. It's usually used for the viewports and for any detail in the drawing you don't want to print. So select the viewports and go to Properties and change the layer to Div Points. Now to print the drawing, we need to insert the title block we created together in Tutorial 8 of this course. Remember, title block is a template for the sheet you want to print and it involves imperative information to identify the drawing. So I will open Exercise 01 that we did in Tutorial 8 and copy the title block from there. Select the title block and its content, click on Ctrl+C for copy and go to Exercise 08. Click on Ctrl+V to paste the title block somewhere here. If you can remember, I created this title block in Tutorial 8 for A4 sheet. But in this exercise, I want to print the 3 aluminium profiles on A3 sheet, so that I have to scale the A4 title block to the size of A3 sheet. The scale ratio in the X direction will be 420/297, and the scale ratio in the Y direction will be 297/210. Select the title block and go to Properties palette. Change scale X to 420/297 and scale Y to 297/210. Move the title block from its base point to this endpoint mark. Select the viewports and adjust the boundaries to be inside the title block. Click on Scale from the status bar and check 1:1. Double-click inside this viewport, then click and hold the mouse scroll wheel to adjust the drawing position. If the scale is changed while moving, you could simply adjust it back as we did before. Click on the lock sign to lock the viewport and prevent any changes for the scale. Repeat the same steps for other viewports. Then follow me moving and sizing the viewports for better appearance of the sheet. Go to Properties palette and change the layer to 0. Draw rectangles over all the viewports. Select one of the rectangles, right-click with the mouse anywhere and choose Select Similar from the list. Go to Properties palette again and change the color to gray number 9. Type LT to access Line Type Manager. Click on Load, scroll down until you find Dashed and click on OK. Select all the rectangles again and change the line type to Dashed from Properties palette. Also change the line type scale to 0.2. Change the layer to Title Block and go to Text Style. Select Title Block Info Style and change the text height to 3. Click on Apply and Close. Choose Title Block Info and click on Multi-Line Text to type the drawing title. Tutorial 15 Exercise 08. Select the drawing title and increase the height to 4. Type the drawing scale 1:1. Type the date. Type the drawing number YT for YouTube, CAD for AutoCAD, TT15 for Tutorial 15, EX for the exercise, and 008 for the exercise number. Type 0 for the revision and 1/1 for the sheet. If the title block includes a logo and for some reason the logo disappears when you copy the title block from one drawing to another, we can help AutoCAD to locate the logo and resolve this issue by using the xref command. This is my logo and the status shows that it's not found. Click it twice, locate your logo and click on Open. Click on Ctrl+P to open plot setting. If this window pops up, just click on Escape button. Click on Preview to check out the drawing before making the printout. Click on Print. Choose a folder. Type the file name and click on Save. In this tutorial, you practiced many tools from the Draw and Modify panels, but mainly it focused on the use of chamfer, stretch, and polar array commands. Sometimes I executed the commands using the shortcut, and sometimes from the ribbon so you guys can be aware of the tool's location on the interface. If you have doubts about any command, you can always go back to the previous tutorials, specifically tutorials 1 to 6 to learn more about it. And you can use the timestamps in the video's description to skip around to any chapter or subject you want to revise. One more thing to do, don't let this video end without subscribing to the channel and ring that notification bell to stay updated.